Hello everyone, welcome back again to slope stability analysis using PLAXIS 2D. This is tutorial number 2, overview of limit equilibrium versus finite element method for slope stability analysis. So in this tutorial, we will understand the principles of limit equilibrium method and finite element method for calculation of factor of safety of a slope. Also, we will compare their assumptions and also we will mention some advantages and disadvantages of these two methods. Also, we will mention why in some complex slope stability problems it is important or it is necessary to use finite element method and software such as PLAXIS 2D. So first let me explain the limit equilibrium method. So it's one of traditional approach where the slope stability is estimated by balancing the resisting force, which is a shear strength of a soil, versus a driving force, which is a gravity or external loads, and also along pre-assumed failure surface. So assume we have a slope like this one. First, by this limit equilibrium traditional method, first of all we pre-assume a failure and we assume this is a failure surface for this ground slope, and after that we calculate the resisting force, which is the shear strength resistance along this pre-assumed failure surface, and also we calculate the driving force, which is the weight of this soil wedge, and the ratio of this resisting force is called a factor of safety of slope. There are many popular methods which are based on limit equilibrium method, such as Swedish circle method, ordinary method of slices, Bishop's simplified method, Jumbo's simplifies method, also Spenger's method, and some other methods as well. There are some charts and curves are available in many geotechnical engineering textbooks, such as Braja, M, Das, etc. So you can find most of these methods in geotechnical engineering textbooks. So some of them are simple and there are also some curves and charts can easily be used to calculate the factor of safety for a slope. Also, there are many softwares which are based on limit equilibrium method, such as Geo5 and GeoStudio, which are commonly used to calculate the factor of safety of slope based on limit equilibrium method. So this method also has some disadvantages, which is only calculate the factor of safety, but it cannot show the stress strain behavior, so we cannot see the deformation in the slope or deformation contours. Also we cannot know deformation or progressive failure information. We don't see where is the exact failure of the surface, because we pre-assume the failure surface and we need to assume many surface, and the factor of safety, the pre-assumed surface which has the minimum factor of safety, we assume that is a minimum factor of safety for this slope. Also it is not easy to estimate the pore water pressure inside the slope, or we cannot also use the reinforcement effect using these methods. So in general, when the factor of safety is less than 1, it means the slope is not stable, it is a failure slope. And when the factor of safety equal 1, it means the slope is just stable, but it is on a verge of failure. And when factor of safety is greater than 1, it means the slope is stable. However, for most practical case, the factor of safety for slope should be greater than 1.5. So in case of finite element method for slope stability analysis, in numerical method, the soil is divided into small elements, which is called a mesh, and in finite element method, we should use, or we should select a suitable soil constitutive model, such as Mohr Coulomb hardening soil model, or hardening soil model with a small strength, etc. And after that, we in finite element method, the shear strength reduction method is used to calculate the factor of safety. So in this method, the shear strength properties of a soil, cohesion and internal friction angle are gradually decreases until the failure occurs. So the factor of safety equals the original shear strength of a soil divided by a reduced shear strength of a soil. So as an output, we get the factor of safety from this method. Besides the factor of safety, we get the deformation patterns in the slope, also the stress distribution and pore water pressure, and also progressive failure development in the slope. So as an advantage for this method, we don't need to assume the failure surface, as in case of limit equilibrium method, we need to assume a failure surface first. But in finite element method, we don't need to assume a failure surface, so it generates automatically, and also it handles complex geometries. For example, when we have many soil layers, or when we have a complex geometry of the slope, or when we have a reinforcement or a water condition and effect of rainfall, etc. So these can be easily calculated, and the effect of these factors can be easily accounted in finite element method. Also, it provides a deformation and stress pattern inside the slope, not just only the factor of safety. Also, we can see or estimate the effect of dynamic loading or earthquake, consolidation and seepage using this finite element method. However, there are also some disadvantages of this method. For example, it requires soil parameters and calibration. Maybe sometimes we don't have, as I mentioned before, when we using the finite element method and PLAXIS software, we need to define the soil using a suitable constitutive model, such as Mohr Coulomb hardening soil model. And these models needs a specific soil parameters. Maybe sometimes we don't have in hand these soil parameters, so we need to estimate it, and if we don't estimate it correctly, maybe we get incorrect results from the software. Also, it needs more computational effort, and knowledge also is needed. So as a conclusion, in here we can see the comparison between the limit equilibrium method and finite element method in PLAXIS 2D for slope stability analysis. So as a failure surface, in limit equilibrium method, the failure surface must be assumed, but in finite element method, it develops naturally. A factor of safety calculation In limit equilibrium method, it's equal a ratio of resisting force divided by driving force, but in finite element method, it's calculated by shear strength reduction method. So we will explain this method in a separate tutorial as well. So soil properties which we needed in limit equilibrium method are simple, which are cohesion and internal friction angle of the soil, also unit weight. But in finite element method we need advanced soil parameters, because most of the soil conservative models are non-linear. So for the effect of water, it is very simple in limit equilibrium method, but in PLAXIS we can use a fully coupled flow, steady or transient. As an output, we only get factor of safety from limit equilibrium method, but in finite element method we get factor of safety, stress distribution, deformation pattern, and also pore water pressure. And in terms of complexity, it is simple and quick for limit equilibrium method, and in finite element method it's advanced. As I mentioned, it requires many parameters. So as a usage, in limit equilibrium method, it is useful for preliminary design, simple slopes, etc. But in finite element method, we can do it for complex slopes and critical projects as well. So this was for this tutorial. I hope it is useful and understandable, and see you in the next tutorial.